Beautiful. All right. So today we're reviewing, right, with this warm up on how to calculate the weighted mean of the data. And I hope you guys see here, the data that you're focusing on right now is the starting salaries, right? Since I'm looking at the salaries, right? The data, my X value is actually going to be the cash value of these salaries, right? So X here is going to be 45,500, and the other X data point is 32,000 exact, right? So those are my data points because that's what I'm looking at. I'm looking at these starting salaries, and that's the values that I have for my X's. So if you're still confused on which one's your X, which one's your W, what usually helps is what are you calculating the average of? And that's what's going to go into there. The other numbers then will probably be your weights, right? 45,500. How many people have a salary of 45,500? There's 8 people that have that. That's the weight for this one, right? That's the weight for this one. $32,000. How many people have that as a starting salary? That's going to be 17, right? 17. So once you have that set up, the calculation for the weighted mean is this guy right here, which I know you're like, that looks so confusing, but it's not that much different from a regular average, right? The regular average is the sum of all your data points divided by how many data points there are, right? How many data points there are. And that's very similar to this, except now you just have to multiply by a W and divide by the total W, right? That's kind of like what the N is. N is like the total W, right? So in this case right here, I'm gonna go ahead and write this down. So my total W, I hope you guys see, is 25, which kind of makes sense because I'm looking at 25 employees. This column over here is going to represent the X times the W, right? And I saw some of you guys actually wrote that down in your chart, and I appreciate that you did. Even if you didn't write it down in your chart, you guys were able to write down the total at the end of it, and I appreciate that as well. Show as much work as possible when you do my free response questions. It just makes it easier for me to give you points just in case you get it wrong, right? Like I was saying, if you do this part right here, which is like show the table and you show and you fill it all out and you got the final answer wrong, you're still gonna get 4 out of 5, right? If you did all the work in between and listed it all out correctly, you still get 4 out of 5. It's not me being generous, it's me being fair. I feel like if you did the work correctly, but the calculation came out wrong, then, you know, that just means that it was like a 1-point deduction. I should not harm your whole problem for that. So this is 364,000 is what you should have got here. And then this one over here is going to be 32,000 times 17. That's going to give me 544,000 right here, right? So the sum of those numbers is going to give me plus 364. It's going to give me 908,000 as my sum, 908,000, right? So to calculate my average, right, average is just going to equal to this guy right here, 908,000 divided by the total weight, and the total weight is 25, which is going to give me, again, just plug it into my calculator here, 36,320. 36,320, and that's it, guys. That's the average starting salary at this company, right? That's the average starting salary at this company. Hopefully you guys are feeling comfortable with calculating the weighted means. It's not that different from calculating an actual mean, right? It's not that different from calculating an actual mean, because all this means, by the way, all this means, get it? Means. So all this means is there's 8 people with 45,500. Technically, what I'm supposed to do is write down 45,500 8 times. I know this is weird, but I'm going to just show you what this is. Oh, God. That's 5. That's 6. And that's 7. Right? Is that 8 yet? No, one more. 45,500. Right? And what essentially is happening is when you write this down 8 times, right? When you calculate averages normally, you're supposed to add all this up, right? Try that. Try writing all these down and adding it up. Guess what you're going to get when you do that, by the way? You'll get exactly what you found right here. So you can see the weighted means looks confusing, right? but it's just a shortcut, really. Instead of you writing this all down because there's 8 people that get paid this amount, and you're just doing 8 times that. And that gives you the same thing as you were to add this up 8 times. Hopefully that makes sense. And if it doesn't, that just made you more confused, ignore what I just said, and we're going to go ahead and move on and just hopefully you get it the way that we were doing it earlier. Okay? So that's all the weighted mean is, by the way. It's just a way to help you calculate it. Right? And I tried to show you that with the bank account last time as well, right? There's like 16 days where the guy had $759 in there. Well, we could also, or 15 days, and you can just multiply by that, and it'll give you the same thing. And that's what we did last time, right here on the screen. So we're going to move on. And then we moved on to this guy right here, which was calculating the mean of grouped data or in classes, for example, right? And of course, you looked at this thing, and these are the steps to do it, and they look horribly confusing because there's 4 steps there, and it looks like, oh my gosh, what's this, all this stuff here that I have to do? And then of course, I show you right here, it's actually not too bad, right, to calculate the mean given a frequency table. You simply have to start off by calculating the midpoint, right? You have to start off by calculating the midpoint. So if my class is from 7 to 18, the midpoint is what we did back in 2.1, and it came out to be 12.5. That's going to be our X value. Just like the salaries were in the other one, this one is going to be the X right here. And you'll say, well, Nagmi, didn't you tell us to look at what it is that we're measuring here? And they tell us in this problem, they're actually calculating the mean of the number of minutes that a person spends on the internet, right? And the number of minutes is right here, 7 to 18. So the idea is we don't know what to use, either the 7 or the 18 or all the numbers in between, like 8, 9, 10, 11, 12, 13, 14, all the way up to 18. So what we do instead is we just pick the number that's exactly in the middle, and that number that's in the middle represents this class, right? This 12.5 represents all of the numbers that are between 7 to 18, and it's like a nice average of that class. Does that make sense? That 12.5, that midpoint, represents all the numbers that are in this class right here. That's what the 12.5 represents. And then that's what we use to multiply with our weight. Except we don't call it weight in this time. We call it the frequency. Just like over here on your warm-up, on your touch screen is all kinds of, my finger's dirty or something. Anyways, so the weight right here is just like the frequency. Can you see it? There's 8 people that make this amount of money, right? It's like the frequency. That's how frequent that a value shows up. It shows up 8 times, right? Down here, they tell us that it's the frequency. How many people are using the internet between 7 to 18 minutes? There's 6 people there. That's like the weight, except they call it the frequency, because that's what we did when we were doing these frequency tables back in 2.1. And I'm trying to help you see that they're all connected. They're all the same thing. Because all I did was take the 12.5 and multiply by the 6, and I got this value over here. And I did that for all of these, right? And then down here, I just simply added them all up. This down here is the sum of your X times your weight, but we just don't use the weight button. We use the F button. The frequency, I shouldn't say that. Your data point times your frequency, right? And then, of course, once you get that value that's down there, this 2089 gets divided by the sum of your weight, but it's the sum of your frequencies, and they just call that N. That's all it is. They just call it N, and that's what goes down here. And then once you do that, that's your answer right there, the 41.78. So looking at this frequency chart, we were able to calculate the average number of minutes a person spends on the internet. And the average comes out to about 41.78 minutes, right? 41 minutes, 42 minutes, I should say, on average there, okay? I know this is like, what the heck? It makes a little bit more sense once we just have you guys try a problem. So we'll do this one together. So this is a you try, but we'll do it together, okay? So I'm gonna switch the Pear Deck right now. There's only 18 of you guys out of 33 on my Pear Deck right now. I really wish you guys would open this up, just so it makes it easier for me to see who's actually here attempting the work. So if I'm gonna put the link back in there again. So if you could please go into this Pear Deck, log in with your name, right? It helps me out just to see how you're doing. I can actually see if you are getting this or not based off of this Pear Deck, right? It's one thing that helps, but if not, well, I don't know what else I can do to help convince you. I am just some guy on your screen, right? can't actually reach through the screen and tell you to do something. No, I can't. That'd be weird. Anyways, let's take a look at this problem right here. All right, let's take a look at this problem. They actually set it up for you. They actually tell you what the midpoint is already, right? So we need to calculate the average price of a GPS navigator. The average price of a GPS navigator. Wow, that's really expensive. They have one of the prices at like $395 to $450. It's a very expensive GPS navigator. All right, so to calculate the mean price, right? To calculate the mean price, right? It's going to be X bar. Since it's a frequency distribution, right? The equation is going to be the sum of X times your frequency divided by N. But of course, hopefully you remember that N is just the sum of your frequencies, right? And which are going to be these guys right here. So you guys see right here, right? This is my frequency. My midpoint is my data, right? My representation of my data, right? Because again, if I was trying to multiply by this 5, right? If I was trying to multiply this 5, I don't know what to multiply by. I don't know if I'm going to multiply by the 59 or I'm going to multiply by the 114. So what we do is take the difference between the two of them, right? Or get the average between the two of them. And the average between the two of them is 86.5. And how do you get the 86.5, you might ask? Take these numbers right here, the 59 and the 114. Let's do that in red. 59 and the 114. It'll just be 59 plus 114 divided by 2. That's how they get the 86. Okay. So in the future, they're not going to tell you what the midpoints are. You'll have to find them, but it's not that hard, right? Just look at the numbers on the classes, which you've learned how to calculate back in 2.1, and find all the midpoints, right? So following here now, I'm trying to find out what X times F is. So I'm going to make myself another table right here, and I'm going to label it X times F. And I'm going to write those values into this part of the table. So how do you calculate that? That's going to be this one right here, which is going to be 86.5 times 5. That's all. That's all you need to do. 86.5 times 5. Go into your calculator and type that in. 86.5 times 5, and you get 432. If you guys already got the 432.5, awesome job. Keep up the good work. 432.5 is that first one right there. You guys get the rest of them for me? You guys get the rest of them for me? I'll give you guys about a minute. Can you multiply all the midpoints with the frequencies and write them down onto your pair deck for me? Let's go with a minute and a half. And then I'm going to cheat and just write off you guys. 1.5 minute timer. And Google is amazing, by the way. 1.5 minute timer is the same thing as 1 minute 30 seconds, right? But I don't have to type out 1 minute 30 seconds. I just type in 1.5 and it does it for me. There we go. So can you guys keep going? Mariah's already on a roll. You are flying through that. You're flying through that. The sum of your frequencies, you already got it, is 30. That is beautiful. That is beautiful. Jasmine, that is a beautifully drawn box. That line right there is perfect. Kevin, nice job. Nice job. A Carwin? I gotta get your name. Every time I look at your name, I'm hesitating. I need to make sure I just get it the first time. A Carwin, looking good. Looking good. I like that you're adjusting those numbers, by the way, to get them to fit. Brenda's working through there. Not bad. Oh, I like it. You're actually showing the multiplication. That's beautiful. Keep going, Brenda. Keep up the good work. Michael, good job on that. Keep going. If you feel like you're confident with this, you can keep going if you feel confident with it. If not, you can wait. If you want to wait for me. All right, Jared, good job. Good job. Keep going. Keep it up. Christina, I like it. You did the sum of the frequencies there at the bottom. That's beautiful. You do know that we are going to need that. Patricia, I like those lines. Those are beautifully drawn. You're making it so it's easier to see, I'm assuming. Those look nice. All right. Let's take a look here. So I'm going to cheat, and I'm going to pick one of these answers, and I'm going to have you guys double check if they're right or not, okay? I'm going to have you double check if they're right or not. Let's see here. I'm gonna trust you. Kevin, I'm trusting you, all right? I'm getting your numbers down. So if anyone got different numbers, blame Kevin. Don't blame Knock Me. Never blame Knock Me. It's never Knock Me's fault. It's always someone else's fault. Never mind. All right. So Kevin got for the second one, 1,140. The third one, he got 1,191. The fourth one, he got 1,272.5. The fifth one, he got 621. Next one after that was 366.5. And the last one he got was 1,267.5. All right, those are the numbers that Kevin got. And if it's wrong, again, don't blame me, blame Kevin. What did you guys get? Did you guys get the same numbers? I think you guys got the same numbers. Mostly. Yeah. All right, I got the same, it looks like. So Carlin, you got the same numbers as well. Brenda's got, yeah, the first three are matching with mine and Michael's. Right, okay. So that's that. So it looks like you were right, Kevin. Yeah, looks like you were right. Nice job, nice job. Very good, very good. So some of you guys have already started moving on, right? Because you guys see that x times f is every number that's in this chart right here, but you also need to do this part right here, which is sum them all up, right? And that's going to be at the very bottom down here. I'm going to write that down here. This is the sum of my x times my f, right? So I just add them all up. I'm going to use the calculator here. I'm not going to cheat anymore. I'm going to go ahead and do the calculation. 432.5 plus 1,140 plus 1,191 plus 1,272.5 plus 621 plus 366.5 plus 1,267.5. That gives me a total of 6,291. 6,291. That's my total right there. That's my total right there. Of course, I'm going to do here the sum of my frequencies. Right, the sum of my frequencies is equal to, I think I'm going to cheat again. You guys actually wrote down 30. I'm just going to trust you on that. And by the way, that sum of my frequencies is the same thing as my n, right? That's the same thing as my n. That's all n represents, by the way, is the sum of your frequency, or your sample size in this case. All right, you've done all the hard work, guys. You're pretty much done. Once you have these numbers right here, the average is just going to be those numbers divided with each other. Right? It's going to be the 6,291 divided by 30. And that's all that is. That's this number right here. And that 30 comes from this number down here. That's all that is. Plug that into a calculator, see what you get, divide that by 30. What's the average price of a GPS machine, a GPS navigator? This thing right here is going to come out to be $209.70. $209.70. And that's it. That's my answer. I see you guys typing it out. That's beautiful, guys. How do you feel about calculating these averages? I'm hoping that it's not too bad, right? Hoping that it's not too bad. If it is, you guys got to let me know, because I only have 11 responses on here, and all the 11 students that are doing it, you guys are doing a bang-up job, and you're getting the same answers as I am, because I'm stealing your answers, but it's right? That's what's important. And for the rest of you that aren't following along and that aren't doing it, can you guys let me know in the chat? Are you guys doing okay with this? Do you feel confident with this? Are you lost with this? I'm doing it in Kami. That's perfectly fine. I'll see it in there as well. I just need to make sure. Are you guys okay? Does it make sense? Have I lost anyone? Right? Have I lost anyone? Or you feel like, you know what, Knock Me, it's not that bad. It's not that bad. I'm lost. All right, Grace. Thank you for being honest, right? What the heck is going on here, right? What the heck is going on? So, yeah, Grace. So this whole chapter, by the way, this whole section of 2.3, right, is us having to calculate an average, right? That's what this X bar represents, is having to calculate an average, right? So I don't know. I'm gonna scroll off to the side here right now, just for a quick side note here, Grace. If I had a numbers like 3, 5, 7, 13, 20, 31, and I've had these numbers right here, and I asked you, hey, Grace, can you tell me what the average is of these numbers, right? You'd be able to do this one, right, Grace? You know how to calculate the average given these numbers right here? I'm hoping, right? And if not, yeah, I'll write it out for you. It's going to be 3 plus 5 plus 7 plus 13 plus 20 plus 31, right? And then, of course, you divide by how many there are. And there are 1, 2, 3, 4, 5, 6. And you divide by 6, right? And that's it. That's your answer. That's your average, okay? Our problem is sometimes they don't give us the numbers. They give us these tables, right? They give us these tables, okay? And it's our job to calculate the estimated average based off of this table, right? So what happens then? Well, let's say instead I didn't have the numbers written like this, but instead of this 20, let's say, for example, I had another 13, right? And doing this by hand, you can just see that that 13 is just going to be this 13 right here that you would still add up together, and that doesn't change anything. What I'm trying to show you is, though, if you have numbers that repeat themselves, you can do a shortcut here. You can do a shortcut here. And what I'm saying is, if there's 13 and there's 2 of them, we can just take that 13 and multiply by 2, right? 13 times 2 would give me 26, right? And what that represents here is me doing a shortcut for this part right there. Instead of me writing out 13 plus 13, I could just write this out as, you know, this whole thing, 3 plus 5 plus 7 plus 26 plus 31. And if you notice, though, when you do that plus 36, that 2 is like your weight. It's like your frequency. So the total number of numbers that I have here is still going to just be 6, right? So it doesn't change that value. It still keeps it the same there, right? So what we're doing is like we're making a shortcut pretty much, right, for these numbers that repeat themselves or numbers that I don't know what they are. On this table, I have 5 numbers that are between 59 and 114. I have no possible way of knowing, just if I only look at this table, I have no possible way of knowing if I have 5 numbers that are 59, or if I have 5 numbers that are 114, or if I have 5 numbers that are anywhere between those values. Like, for example, 60, 61, 62, 63, 64, 65. 100, 102, 103, 104, 110, 111. I don't know what those numbers are. I just know that there's 5 of them that are between here, right? Oh, darn it. Sorry, I locked out, my internet cut off. So you might have lost out on everything I was explaining there. Well, shoot, I don't know where to continue from, but you might have to just go back and watch the video of me explaining that part, Grace, and hopefully it'll make more sense. But if not, I'm going to continue where I left off. I know, sorry. I'm going to continue where I left off, and I promise you, if you rewatch this part of the video, look like 30 minutes in where I say your name, and then hopefully you'll catch up on here. But what I'm trying to say is us finding the average, right, using this method that looks weird, this guy right here, is just a shortcut for us to calculate the average when they give us a table, right? Because you knew how to calculate the average given a bunch of numbers, right? Well, what happens when we don't know what those numbers are? They instead just tell us like, oh, there's 5 numbers that are between 59 to 114. We have to do our best to estimate it. And that's what this number represents. This 432.5 is technically an estimate of adding up all the numbers, all 5 numbers that are between 59 and 114. If you don't believe me, check this out. Give me Grace, pick a random number from 59 to 114. Just any number that's between there, from 59 to 114. Just type it out in the chat. What's a random number? 30? No, it has to be between 59 and 114. Between 59 and 114. 87. Okay, 87. All right, that's one random number. Can I get another random number from someone else that's between 59 and 114? I need 4 more numbers. So if you guys can just randomly assign yourself and just pick a number between 59 and 114. Can you guys do that real quick? Mariah's typing out 69, right? Aha, nice. 69, 100. All right. Hold on. 100. I want to go in order there. 73, and I need one more, and it looks like we'll go with 69 again. So those are 5 numbers right there. All right, Grace, those are just 5 random numbers that are between 59 and 114. if I add up those random 5 numbers, I'm going to get, check this out, right? If I do it the old-fashioned way, right, this would be 87 plus 69 plus 100 plus 73 plus 69 again, right? I get this total of 398, right, Grace? 398. Look at what we got. Look at what we got. We got 432. It's close. You see that, Grace? That 432 is close to what the actual number is. The actual number in this case would be 398. And that's okay. We're not going to get it perfect to match. That's almost impossible, but it's close enough, right? That 432 represents an estimate of me adding up the 5 numbers that are between here. Does that make sense? Hopefully it does. If not, let me show you another one. I need you guys to help me out in the chat again. Can you guys give me 3 numbers? Let's do this one in pink. Give me 3 numbers that are between 395 and 450. So just right now, type in the chat. 3 numbers that are between 395 and 450. 369. That's not it's not in between 395. So it has to be 395 to 450. So we got 444. I guess we could do 396 if you want to switch that around, Grace. 396 is between that, and then the last one, let's go with I'm sorry. It's 395. But yeah, I'll just switch your numbers around. So 396. And then one more, we'll go with 400. Oh, there's a bunch of other ones. But we only need 3. We only need 3. Sorry if I didn't get your number. But see here, these are the 4 data points that are between 395 and 450, right? And there's 3 of them. What we're going to do now is sum them up. So I add this up. 444 plus 396 plus 400. See, that total comes out to 1,240, right? That total comes out to 1,240. And it's close to what we got as our estimate, right? The actual value should have been 1,240. Our estimate came out to 1,267.5. And that's what we're doing here, right? That's what we're essentially doing. We're getting the totals without actually having to go into our calculator and adding them all up. I don't actually have to do this. By the way, there's 30 numbers, right? And sometimes you'll deal with data points that had like 80 numbers. And I really don't want you to sit there and type in 80 numbers with a plus sign in between all of them. Instead, you could just multiply the midpoint, right? The average of these numbers. So the 59 and the 114 right here, I just calculate the average. That's how I get this midpoint. That's how I got this midpoint of 422.5. I just averaged out the 395 and the 450. And then multiplied that number with the how frequent it showed up, and it gives us an estimate of it. It's close enough to us adding them up together. Does that make sense, Grace? Hopefully it does. Right? So the numbers that are here, this x times f, every number that's in this row highlighted in yellow is supposed to represent us adding the numbers that are between each of these classes and then multiplying with how frequent they showed up. So if there's 8 numbers here, there should be 8 numbers between this value. I just multiply it with this one to get an estimate of it of 1140, right? There are 6 numbers here with a midpoint of this. This right here is an estimate of me adding up those numbers. And you just do that. Yeah, that's right, Grace. You just do that for each of the classes, right? So there's 5 here, and I do an estimate of it, and that multiply with that. That's how I got that number. Right? I should have shown this right here. So the numbers that are all here is just the estimate for each of the classes times how frequent they showed up. So this is 142.5 times 8. Right? This one right here is supposed to be 198.5 times 6. Right? And you do that for all of them. That's all that is. All those numbers are the sum of what we think could be the values of them, because we don't actually have the values of them. If we did have the values, you could just add them all up and divide by how many there are. But we don't have that data. We only have the classes there. So this right here is an estimate of me pretending I knew what those numbers were and I added it all up. And that's where that 6,291 comes from. And then once you get the total, right? Once you get the total of something, right? You simply divide by how many there are. And that how many there are comes from your frequency chart right here. Add it all up. And that's where that 30 comes into play, because there's 30 numbers in there. That's why we divide by that 30. And that's how that works to calculate your average given a table, That way we don't have to, if we don't have the numbers, we don't need them. We could just do it based off this table. Hopefully, Grace, that makes a little bit more sense. And hopefully for anyone else who had questions but didn't, was too hesitant to ask, hopefully that helped you out as well. And you feel a little bit more confident with this. And if it didn't help, you can always just memorize the steps, right? The steps is basically take the midpoint, multiply by the frequency, add them all up, and then divide by the total frequency. If you just want to memorize those steps and just memorize this equation, or write down in your notes that you need this equation for calculating the mean given a frequency distribution or a table like this, you can do it that way as well, as long as you get the answer, right? As long as you get the answer. But I would love it if you understood how that answer came to play. But, for now, if you just want to do it just for your homework, just for the quiz, just for the tests, you can memorize it for now and just learn it later. That's usually how most of the time it's done. It's actually really hard to learn things. But once you get the idea of how to learn things, man, school becomes so much easier. But I understand that that's actually a little hard. That's actually a really hard concept to do, is actually understanding something fully. But that's okay. I believe that you guys can do it. Right? I believe it. That's the only reason why I will take the time and go through this stuff and explain things thoroughly. Even though some of you guys are like, I already know how to do it, I already know how to get the answer. I think it's worth the time to go through and explain those things and understand a little bit better. Anyways, enough philosophical talking, right? Let's keep going here. I'm going to talk about the shape of distributions when you actually plot the histogram or these guys, or the bar graphs of these guys, or the dot plots of these guys, right? It actually, so you could look at it as a bar graph, you could look at it as a dot plot, right? All of those things are important, okay? So let's take a look here. I don't think, is there anything for you to actually write down on these guys or not? If not, you can just write down the stuff that I have to say about them. Anyways, so if you draw a dot plot and or a bar graph, and the shape comes out looking like this shape right here, right? It could just be a bar graph. It could also be a bunch of dot plots that you have that follow this right here. If your shape comes out looking like this, and it's perfectly the same on the left side and the right side, and it's cut down right down the middle like this, we call this a symmetric distribution, a symmetric distribution. A symmetric distribution basically just says that you could draw a line somewhere on this graph and it will split the results perfectly in half. Perfectly in half. If I drew a line right here, pretend that that was a straight line that went through the middle. Like that, right? Then I could say that 50% of my data is on this side and the other 50% of my data is on the other side, because it's a perfect symmetric distribution, right? They mirror themselves pretty much, right? That's the first one up. And you guys have seen a symmetric distribution before, I'm pretty sure, when you guys were taught about the normal curve, right? Do you guys remember the normal curve? If not, it'll come back to you today. Hopefully, if I have some time, we'll get to it today. But yeah, that's all a symmetric distribution is. It makes something that is symmetrical around a vertical line that you can draw somewhere in the middle there. Okay, so that's the symmetric distribution, right? All right, let's keep going then. The next one is going to be a uniform distribution. In a uniform distribution, just like a bar graph or like a dot plot, they have the same number of entries for all of their data, right? It has the same number of entries for all of their data, right? All entries or classes in the distribution have an equal or approximately equal frequency, meaning that if I was giving every person the same amount of, like, let's say, I don't know, the same. That's not the right way of thinking of it. What's a good way of something that's perfectly uniform? Let's say I was trying to run a class like a horrible teacher, and I wanted, if I had 5 people who got A's, I also want 5 people who got F's. I want 5 people who got B's, 5 people who got D's, and 5 people who got C's. That's uniformly distributed across the grades, so they have 5 A's, 5 B's, 5 C's, 5 D's, and 5 F's, right? That's terrible, but that would be uniform, right? And if I was like obsessive compulsive about that and I want my data to be perfectly exact all the way across, I would go in there and say, oh, this person, I need you to have an F in this class just so that I have 5 F's, 5 D's, 5 C's, 5 B's, and 5 A's. That way it forms a nice flat line across. That would be something that's uniformly distributed, right? That's horrible, by the way. I would never run my class that way, but you know, I hope no teacher actually runs their class that way. But that's one way of looking at it as it being uniform, is that there's exactly the same number of one thing compared to the same number of another thing all the way across. Okay, all the way across. All right. So that's uniform distribution. They also call it rectangular. And I hope you can see why they call it rectangular. It just looks like a rectangular shape. Right? Hopefully. And that one doesn't show up as often. But it is a possibility. If everybody has the same amount of something that they're dealing with, that it will come out uniform. Okay? All right. Now here's where things start to get confusing. All right, here's where things start to get confusing. There's a skewed left and a skewed right distribution. And this is the part that's always like weird to me, right? When you think of something skewed left, you kind of expect the hump to be on the left side, but it's not. You see this one right here? This one is skewed left, but you see the hump is actually pushed towards the right. I hate skewed questions or I hate skewed cues. Yeah, they're kind of weird. They're kind of weird. Questions, yeah. They're not too bad though, like once you get the hang of it. But a skewed graph, right? Skewed left doesn't necessarily mean the hump is going towards the left. You see that? When you're talking about skewedness, you're actually looking at this thing called the tail. You're looking at this thing called the tail, right? So if a data is skewed left, that means that it has a longer tail on the left side, right? That's all it is. So if it's skewed left, your tail on the left side should be longer than your tail on the right. That's all it is for it to be skewed. And the reason why that is the case, give me a second here. Oh, come on, knock me. And the reason why, right, is because of outliers, right? You have an outlier somewhere in there, it's going to skew your data. And just like we learned earlier earlier in this chapter, this section, right? When you skew your data, your mean gets pulled towards that skewed data, which also then pulls your tail, which makes it skewed towards the direction of your outlier. So I have an outlier over here on the far left side of this example, which pulls my mean to the left of my data, which skews my data towards the left. And that's why, even though the hump looks like it's to the right, right? The hump looks like it's to the right. When you're talking about skewed, you're focusing on the tail, right? So that's why right here, when I say it's skewed left, that means that the tail has a longer tail on the left side. And if I'm talking about skewed right, the tail on this guy is longer on the right. Do you see that? That tail right there. Does that make sense? Hopefully it does. And some students always get confused by which one's skewed left and which one's skewed right. The tip I always give is just look for the tail, right? Where's the longer tail on there, right? If I had, for example, a dot plot, horribly drawn dot plot, right? If I had a dot plot that looked like this, right? You can kind of see this is considered skewed left, right? And that's because it has a longer tail over here, right? It has a longer tail on the left-hand side. That's all it is when you're looking for. We're skewed left and skewed right. Where's the longer tail? Okay, where's the longer tail? All right. So let's take a look at a couple of these guys. Okay, let's take a look at a couple of these guys. And I'm going to ask you guys to do the poll into the chat right here. Oh, I'm gonna see if this works out. Let's try this. I want to see if this works out. I haven't tried this yet, but this will be fun. For number 21, right? You don't type it into the chat. You're gonna select this poll. Is it? Let me try this out here. I don't actually know if this is gonna work. Metric, uniform. Add another option. Skewed left or skewed right. I'm gonna go ahead and launch that right there. Can you guys look at this one right here? Number 21. Do you think this is considered symmetric, uniform, skewed left, or skewed right, or none of these? I should have added that in there, but oh well. Try that out. Does it show up? Can you guys see that poll? Right? And then for 22, I want the same thing. What do you get copy? Can I copy? No, I can't. Dang it. Is number 2 symmetric? I spelled symmetric wrong. Shh, don't tell anybody. Symmetric, it works? Awesome, works. So go ahead and get in there and start voting. Is number 22 symmetric? Uniform. Skewed left or skewed right? I'll launch that one as well. So can you guys go in there and try that real quick? Go in there and go into the polls and answer these questions. Answer these questions. Is it skewed right or is it skewed left? Or is it uniform or is it symmetric? You guys go into the poll and answer that. Ooh, if I click show the results, do you guys actually get to see it? Can you see what other people are voting? Yes, nice, nice. Why are there only 3 votes? Where's everybody? Get in there and vote. Pick, is it skewed left or skewed right? Come on, guys. There should be more than just 3 of you guys responding. 4 of you guys now. Go in there, go in there. It's in the chat. It's not on the Pear Deck. It's in the oh, it's not in the chat. It's in the square, triangle, circle button, I believe, if you click on that. Is that what it looks like on your screen? I actually don't know. Can you guys tell me? Do you have to click on that to get into the polls? I don't know if you guys can let me know. How do you get into the polls? All right, I think you have to click on the chat button on the right-hand side, and then you click on the triangle, square, circle tab. Yeah, it's on the Shapes logo. And then when you click on there, it should say polls. I hope you guys see polls. And then you guys can see which way to vote. Oh, good. There's like 6 of you guys, 7 of you guys that voted now on the first one. Just for fun, guys. It's not something that's like super important, but I like how, playing with these things. So you can vote to see which one do you guys think it is. I don't think it shares who voted for what, hopefully. Right, but we got that in there. And I hope you guys can see that. If I was looking at number 21, what helps me when I look at these problems is I literally take a line and I just kind of trace along there without actually going over the bars. And I look, where do I have a longer tail? Where do I have a longer tail? Where's my tail? Right? And then this one over here, this one's just gonna go straight up. It doesn't even have anything that goes on the left-hand side there, and then it goes down like this. Which one has a longer tail? Where's the tail located? Right? So this right here, I hope you guys can see that this is considered skewed left, whereas number 22 is considered skewed right. Skewed right. So you guys can take a look at that. Right? Isn't that kind of neat? You're just looking at the tail of it, right? You're just looking at the tail. Which one has a longer tail? And in this case, the longer tail for 21 is on the left side, and for 22, the longer tail is on the right side. Okay? So that's that, guys. But now that you know what it's skewed left or skewed right, you can actually figure out which one is going to be greater. So here's the thing. If something is skewed left, right, what happens to the mean? What happens to the mean? Does the mean go to the left or does it go to the right when it's skewed left? And I hope you understand that when you have something that's skewed left, the mean gets pulled towards that direction. So for exercise 21, which is greater, right, the mean gets pulled to the left side, which is numbers that are less than. So what would be greater? What would be greater? Right? In this case, the median is greater because the mean is pulled to the left, which is less, right? It decreases. Very good, Michael. Very good. The mean decreases. I like that term. I like that terminology better, right? The mean decreases because of the skewed left, right? That outlier pulls your mean to the left, which makes it decrease in value, right? For 22, since it's skewed right, right? The mean for skewed right is going to increase, is going to get pulled to the right side, right? So in this case, the mean is greater. Man, my writing is messy. The mean is greater because the mean is pulled to the right, which is an increase or more, which is an increase, right? That's that. Is that okay? Does that make sense when you're looking at these graphs? By the way, you are going to have to figure out, is this skewed left? Is this skewed right? Is it symmetric, right? By the way, if it's symmetric, the mean and the median are the same, right? If it's symmetric, they're going to be the same, along with the mode, right? That's a very special case. So let's take a look here, and then I think we're going to stop here. Yeah, it says a you try, but I think we're going to stop here at the I'll do, will do, right? So take a look here. Take a look here. Here's a stem plot, right? Stem and leaf plot of time, travel time to work for 20 randomly selected New Yorkers. We found the median was 22.5, and the key tells us that a 4 with a line with a 5 means that it's 45 minutes, right? So looking at this data, one person, it only takes them 5 minutes to get to work, and another person takes 85 minutes to get to work. That's nuts, right? So some people take 60 minutes to get to work. Some people take 65 minutes, right? I need you to figure out here, looking at this, does this look like it's skewed left, skewed right, symmetric, or none of them, right? And here's the thing. For a stem and leaf, you kind of have to tilt your head to the side to see it. The curve looks like this. See that? And yes, Calvin, this would be considered skewed right. And some of you guys are like, how is he able to see that when you have the numbers written like this? You kind of tilt your head to the side, right? I'm telling you, and you write it out this way: 0, 1, 2, 3, 4, 5, 6, 7, and 8. And it's kind of curved like this, where that one person over here is 85 minutes, right? 85 minutes to, man, I don't know if you guys can imagine that, spending 85 minutes to go to wherever you need to go every day, and then 85 minutes to go home. That just sounds insane. It's like an hour and 25 minutes. That's an hour and a half. That's 3 hours a day commuting. I wouldn't work there anymore. Yeah, the only reason why that would be the reason why someone would do that is probably because they're getting paid like a ridiculous amount, hopefully. At that point, you would move, right? If you're getting paid a lot, just move somewhere closer, hopefully. 85 minutes. Anyways, I'm getting distracted, right? So I don't know. Can you guys see that okay? Like, y is considered skewed right? Because the tail is over here, right? But you have to tilt your head to see that the tail is existing on this curve, and the tail is to the right. So it's skewed right. Skewed right, right? Skewed right. Based on this stem and plot, would you expect the mean travel time to be less than, about the same, or larger than the median? Since it's skewed right, I'd say the mean is probably going to be larger, right? Is larger than the median. And why? The mean is larger than the median because of that skewed right, right? Since it's skewed right, the mean is increasing and it's going to be larger than the median. And that's where that is. Use your calculator to find the mean travel time. So let's do that real quick. How do you calculate the mean travel time? We simply just I have the numbers here, so I just add them up, right? I just add them up. So the first number is 5 plus the second number is right here is 10. You see that? The second number is 10. So I'm going to go ahead and add that. So it's 5 plus 10. How many 10s are there? There's 2 of them. So I have to add 2 of them. And then there are 4 15s. 1, 2, 3, 4. And then I just keep doing this for all of them. Let's do 20 here. 1, 2, 3. And then there's a single 25. There's 2 of them that have 30-minute travel times. There's 2 of them that have 40-minute travel times. 1 of them that has 45-minute travel times, one person, two people with an hour travel time. Even an hour, I feel like is too much to travel to work. So 60 plus 60 plus 65 plus the last one, which is 85. This is the total number of minutes traveled. How many people are there here? There are 20 total. They tell us that. So I just take that number, divide that by 20. The mean average time of traveling is 31.25. 31.25. That's my mean. Right? My median is the number that's in the middle, and I'm going to do that by just marking it off here. So one off on the right, one off on the right, two off on the right, two off on the left, two off on that side. One here, one there, three there, three there. If this doesn't make sense on how I'm doing the median, don't worry about it. I'm just going here. One here, one here, one here, one here. And the mean looks like it is, the median is about 20. Median is about 20. If you write those numbers out in order, right, like 5, 10, 10, 15, 15, and so on and so forth, and did that all down and look for the middle number, your median would come out to be 20, and my mean came out to be 31.5. So yeah, this was true, right? The mean is more based off of this right here. And all we didn't even have to calculate it. We just looked at the skewed right, but it actually comes out to be true in this case. Would the mean or the median be more appropriate summary for the center of the distribution of the drive time? So looking at this data, does 31.25 look like a better representation of this data, or does the 20 look like a good representation of this data? I'm going to leave it for you guys to answer before you submit your notes. This is the last part of 3.2. And I'm going to leave you to answer part 3 right there of that question with your own words. There's no right or wrong answers for this. That's a lie. There is a right or wrong answer. But I'm not going to judge you if you get it wrong. I want you to think about this question, right? Would you take the mean or would you take the median based off the data that you have here to represent it? And you just type that in and type out Y into here and then submit your notes. We're not going to do the you try for this one. And just go ahead and submit your 2.3 notes with that. You should be done with this. And then the homework is going to be posted online, and it'll be these numbers right here, 9 through 12, 17 through 39 odd, 41, 43, 47, 49, 51, and 53. This is set to be due next week on Wednesday, but remember the conversation I had, right? If you don't do it on time, you can still turn it in late, and I'll still give you the credit as long as you finish before we take the chapter test. And the chapter test won't be for at least another 2 weeks. So get in there and start working on it. And that's it for me today, guys. I went a little bit overboard on time, but you know, that's okay. We finished 2.3. We'll start 2.4 next week, and you have a quiz on Monday. Okay, guys? Other than that, have a good weekend. I won't see you until Monday. Stay out of trouble. Stay out of jail. Don't get pregnant, all right? See you guys. Have a good weekend. So long.